Welcome back to the deep dive. How many times have you stared at a spreadsheet or, a database just wishing you could ask it a question,
Oh, absolutely.
like in plain English, and get an answer back? Maybe even a chart instantly.
We've all been there. Staring at rows and columns, knowing the insight is in there somewhere.
Exactly, that feeling of information overload and maybe the frustration of needing, special coding skills just to get at it.
It's that classic technical barrier, isn't it? The gap between the data and the people who actually need the answers from the data. It's slowed things down for a long time.
Well, that specific gap is exactly what we're diving into today. We're going to explore how artificial intelligence and specifically large language models, or LLMs, are just completely changing how we interact with data.
Revolutionizing might not be too strong a word.
I think you're right. They're effectively tearing down those technical walls,
Mm.
making data accessible in ways that honestly felt like science fiction just a few years back.
Yeah.
So our mission in this deep dive is to unpack how these natural language interfaces are transforming data analysis visualization too. We'll focus on specific tools, specific techniques, like the AI agents you find in the LangChain framework.
Yeah, LangChain comes up a lot here. These agents are really designed to bridge that exact gap, human language on one side, complex data systems on the other.
So we'll look at what they can do, their capabilities, which seem pretty incredible, but also, and this is critical, what you need to watch out for, the potential pitfalls.
Absolutely crucial. And to guide us, we've got a great stack of source material. We're looking at deep dives into AI's role in analytics generally, but also specifics like using natural language for visualization with something called Pandas data frames,
Okay.
all the way to the, let's say, the intricacies of AI-powered SQL agents for databases.
Right, the database side.
Yeah. So we'll explore that core problem, the technical barriers, then this natural language revolution, and finally get into the tools and practices that actually make it happen.
Sounds like a plan. Let's kick off by setting the scene a bit. Thinking about the old way. Historically, getting insights from data wasn't exactly straightforward, was it?
Not at all. It was a highly specialized skill. You really needed to know your stuff. Programming languages like SQL for
The
databases.
standard query language.
Right. Or Python, maybe R, for doing the actual number crunching and analysis. And then you often needed expertise in complex tools like Tableau just to show the results in a way people could understand.
So multiple layers of technical skill needed.
Precisely. And that created this significant, well, knowledge gap. The people who often needed the insights the most, the business users, the decision makers, the folks with deep domain expertise but maybe not coding skills.
They were kind of locked out.
Essentially, yes. They couldn't directly access or leverage the data themselves. They had to rely entirely on data analysts or engineers acting as intermediaries, go through a request process.
And the consequence of that reliance, that friction, it
Yeah,
had to be a bottleneck, right? Slowed
True.
things down.
absolutely. A major bottleneck. If a manager needed a quick sales trend, they couldn't just ask the data. They'd put in a request, wait for an analyst to free up, run the query, format the report.
And maybe by the time they got it back.
Exactly. The moment might have passed or the question had already evolved. That delay really hampered quick decision-making, slowed down innovation. You couldn't iterate quickly on data questions.
Okay, so that's the old way. Lots of friction, lots of waiting. But now the landscape is shifting. You mentioned large language models, LLMs. They're the game changer here.
They really are. They've ushered in this completely new era, a natural language revolution specifically for data analytics. Suddenly, that scenario, we imagined just asking your data a question in plain English, like you'd ask a colleague.
That's becoming real.
It's rapidly becoming a reality, and it's not just about asking.
Okay.
The promise is getting back analytical results, summaries, even visualizations almost instantly,
Without writing code. Like zero code.
without writing a single line of code yourself. That's what LLMs enable. And this is what people mean when they talk about democratizing data access.
Right. Democratizing data. Making it available to everyone.
Exactly.
Yeah.
Opening up these powerful analytical tools to a much, much broader audience, from the CEO wanting a quick sales trend update to an individual just tracking their personal spending habits.
It puts the power directly in the hands of the person with the question.
That's the core idea. Democratizing data access really is the heart of this transformation. It means powerful tools aren't just for the specialists anymore.
So a marketing manager could ask, show me my top growth areas last quarter.
And get an answer, maybe even a chart straight away. Or you, personally, could ask your fitness tracker data, correlate my steps with my sleep score.
And get an insight without needing to export to a spreadsheet and build pivot tables.
Precisely. It fundamentally changes who can extract value from data. But it does raise interesting questions, doesn't it, about the roles of traditional data professionals?
Yeah, what does it mean for them? Are they freed up for harder problems or?
Or does the power dynamic shift? It's definitely something to keep an eye on as this evolves.
Okay, let's dig into the how. How do these LLMs actually manage this?
Yeah.
Bridging human language and complex data.
Well, at its core, it starts with natural language understanding. That's step one. The LLM takes your everyday question, say, what's the average age of our customers?
Yeah.
And translates it
Translates it into what?
into a structured, machine-understandable query format. Think of it like a super smart interpreter, not just for the words, but for the intent behind the words in a data context.
Okay, so it understands the question. Then what?
It goes beyond just understanding the language. It actually performs reasoning about the data itself. It understands the properties of your data.
What do you mean by properties?
Like it knows age is typically a number, so you can calculate an average.
Yeah.
But customer name is text, so averaging doesn't make sense. It reasons about what operations are valid for which data types.
Ah, okay. So it prevents silly mistakes.
Exactly. That's crucial for getting meaningful results. Then from there, it often moves to data processing selection.
Data processing, like cleaning the data.
Yes. The LLM can identify and sometimes even suggest or perform necessary pre-processing steps. Maybe there are missing values in a column that need handling, or maybe a number column got read in as text somehow.
Which happens all the time.
All the time. So the LLM can flag that or even fix it, often automatically, before the main analysis starts, ensuring you're working with clean, usable data.
That's quite helpful. Saves a lot of manual checking.
It does. Then comes the analysis method selection. Based on your question, the LLM intelligently chooses the right statistical or analytical approach.
So if I ask how many, it knows to count. If I ask what's the trend, it knows to look at time series.
Precisely. Simple counts, averages, trend analysis, correlations, maybe even more complex stuff. It selects the appropriate method based on what it understood your intent to be.
Okay, this is building up. Understanding, reasoning, cleaning, selecting the method. What's next?
And this is where, for many people, it gets really interesting. Code generation.
This is the magic part.
Kind of feels like it. The LLM then generates the actual executable code needed to perform that analysis.
So it writes SQL or Python.
Exactly. It could be SQL code to query a relational database, or it could be Python code, maybe using the Pandas library, to manipulate a data frame. It literally writes the code that you, the user, no longer have to figure out.
Wow. Okay, so it generates the code, runs it presumably.
Yeah.
What about presenting the results?
Good question. It doesn't just stop at the raw numbers. It moves to visualization selection.
Choosing the right chart.
Intelligently choosing the most suitable chart type. If you asked for counts of different categories, it knows a bar chart is usually a good fit. If you asked about changes over time, it'll likely suggest or generate a line graph. It aims to turn the numbers into an intuitive visual.
Automatically picking the best way to see the pattern.
That's the goal. And finally, the last step is insight generation.
Explaining what it found.
Yes. It summarizes and explains the results in plain, understandable language. It tries to effectively turn those raw numbers and charts back into actionable insights. It doesn't just dump data on you, it helps you understand what it means for your question.
Okay, so putting that all together, the high-level flow, if I ask a question.
Right, let's walk through it. You, the user, input a query in natural language. Let's use your example. Show me sales trends by region for the last quarter.
Okay.
The AI agent receives that. It interprets your intent. It figures out you care about sales, trends, meaning time, region, and last quarter. It then maps those terms to the actual structures in your database or data file. Like it finds the sales amount column, the order date column, the region column.
So it connects my words to the data fields.
Correct. Then it formulates the precise technical query needed. Maybe that's a chunk of SQL code or some Python Pandas commands.
Which it generated itself.
Which it generated. That query is then executed against your data source, the database, the file, whatever it is, and the raw data comes back.
Just the numbers and rows.
Initially, yes. But then that raw data often goes through some analysis cleaning maybe, applying statistical methods like aggregation or calculating trends. The AI synthesizes these results. It looks for patterns, maybe highlights anomalies, and generates those natural language explanations we talked about.
And
finally, it presents these synthesized insights back to you, often with a chart, definitely with the explanation. And sometimes it might even suggest follow-up questions like, You asked about regions. Would you like to see this broken down by product category within each region?
Guiding the exploration.
Exactly. It becomes this end-to-end analytical assistant working with you.
That's a really clear picture. Now let's zoom in on one of these tools you mentioned earlier, the LangChain Pandas agent. What's that specifically for?
Right, so the LangChain Pandas agent is designed specifically for interacting using natural language with Pandas data frames.
And just to remind everyone, Pandas data frames are basically these really powerful structured tables of data that you work with all the time in Python for data analysis.
Exactly. They are fundamental in the Python data science world. Think of them like superpowered spreadsheets you can control with code. This agent lets you control them with English.
So what's the ideal use case for this Pandas agent?
It's really fantastic for data exploration and rapid prototyping. You've got some data, maybe you just loaded it from a CSV file or pulled it from a database into memory. You can quickly ask questions, get answers, see plots, just to get a feel for what's in there.
Sounds great for initial analysis. But you mentioned a warning before, something about production.
Yes, and this is really important. It's generally not recommended for production environments without putting comprehensive safeguards in place.
Why not? What's the risk?
The core reason is that it involves dynamic code execution. The AI is literally generating Python code based on your input and then running that code.
Ah, okay. I can see how that might be risky if someone asked it to do something malicious or just wrong.
Precisely. If not properly constrained, it could potentially execute harmful code or access things it shouldn't. That's why you'll find it in LangChain's LangChain experimental package. That experimental tag is a signal. Use with caution, understand the risks, probably not for your critical live production system without serious controls.
Got it. Experimental means be careful. So how does this agent, the Create Pandas data frame agent, actually work? What makes it good at Pandas?
Well, a key thing is that it's not like building an agent totally from scratch. This one comes pre-configured. It has a built-in collection of functions and prompts that are specifically tailored for data frame operations.
So it already knows a lot about Pandas commands.
Exactly. It saves you a ton of setup time because it's already primed with knowledge about common Pandas tasks, filtering, grouping, calculating, plotting, and how to translate your English request into the right Pandas code.
And it works directly on the data frame object you give it. So if I load data into a data frame called EF,
You pass that DF object to the agent when you create it, and then any questions you ask are performed directly on that specific data frame in your Python session's memory.
okay, so natural language in, insights out, operating right on my data.
That's the idea. You give it a prompt, a question, and it gives you back values, summaries, sometimes even generates and saves a plot file. It's very direct.
Okay, let's make this practical. How would someone actually set this up? High-level steps.
Sure. Typically, step one is getting your data into a Pandas data frame. You'd use the Pandas library itself, maybe pandas.read CSV, to load a file, say, studentalcoholconsumption.csv. You might look at the first few rows using df.head just to see the column names like sex or age.
Standard Pandas stuff. What's step 2? The AI part.
Step two is setting up your LLM. You need to tell LangChain which large language model you want to use and how to connect to it. This usually involves providing credentials like an API key and endpoint URL for your LLM provider, maybe IBM WatsonX.ai or another one.
Right, you need access to the brain.
Exactly. And you'll specify a model ID, like maybe Llama 370B or whatever model you're using. You also set generation parameter.
Parameters, like what?
Things like max new tokens, which limits how long the AI's response can be, and temperature. Temperature is important. It controls creativity. Lower temperature, say close to 0, makes the output more focused and deterministic, more factual. Higher temperature allows more randomness, maybe more creative interpretations. For data analysis, you usually want a lower temperature.
Keep it factual. Makes sense.
Yeah. And maybe things like topic to further constrain the word choices. You always need to check the specific API documentation for your LLM provider, as these parameters and model names can change.
Good tip. Okay, credentials and parameters set. Step 3.
Step 3 is actually loading and connecting that LLM into the LangChain framework. You'd import the right class, maybe WatsonX LLM if you're using Watson's, initialize it with your credentials, model ID, and parameters. This wraps the LLM so LangChain can use its capabilities.
So LLM is ready within LangChain. What's the final setup step?
Step 4 is setting up the Pandas data frame agent itself. You import Create Pandas data frame agent from that LangChain experimental.agents module we mentioned. Then you call this function, passing it two main things: your initialized LLM instance and your Pandas data frame, DF.
Okay, connect the brain to the data.
Pretty much. You'll also typically want to add verbose.
Yeah.
True. This is super useful because it makes the agent print out its thought process, what it's thinking, what code it's generating, what results it sees, essential for understanding and debugging.
See insights head.
Yeah. And maybe return immediate steps. True if you want to programmatically access the generated Python code later.
Okay, agent created, LLM connected, DataFrame loaded, verbose mode on. Now, the fun part? Asking questions.
Now the fun part. You simply use the agent's invoke method and pass your natural language question as a string.
Like what? Give me an example.
You could ask something simple, like agent.invoke how many rows are in this file.
It would answer.
It would likely come back with something like, there are 395 rows in the data frame. Or using that student data example, maybe agent.invoke how many students are 18 years old.
And the answer.
It would probably respond, there are 82 students who are 18 years old. It figures out it needs to filter the age column and then count the results.
And this is where seeing the intermediate steps, that verbose output, becomes really cool.
Absolutely. This is the aha moment. Because with verbose, true, you don't just get the answer, you see how it got there. For how many rows, you'd see it generated and executed Python code like len df.
Simple enough.
But for how many students are 18, you'd see it generate something like dfdh equals 18.shape0. That's the actual Pandas code to filter the data frame where age equals 18 and then get the count shape0.
Wow. Seeing the code it writes really builds trust and understanding.
It's key. It demystifies the process. You see, it's not just magic. It's translating your request into specific executable code.
And visualizations, can it really plot things just from a sentence?
Yes, this is another really powerful feature, especially for that rapid exploration phase. You can give it natural language prompts asking for plots.
For example.
You could try agent.invoke, plot the gender count with bars. Assuming your data frame has a column like sex representing gender.
Right.
The agent is usually smart enough to figure out that gender maps to the sex column. It will then generate the Python code using a library like matplotlib or Seaborn to create a bar chart showing the counts for each gender category.
And I don't have to write any plt.bar or
Uh-huh.
sns.count plot code myself.
Nope. It handles generating the plot code and often saves the chart as an image file for you, or might even display it if your environment supports it. It really accelerates turning data into visual insights.
That is genuinely transformative for anyone who just wants to quickly understand a data set without getting lost in code syntax. But, okay, Pandas data frames are great for data that fits in memory. What about the really big stuff? The terabytes sitting in databases.
Exactly. That's the natural transition point. While the Pandas agent is brilliant for those in-memory data frames you're exploring, it hits limits with huge data sets. That's where AI-powered SQL agents come into play.
SQL agents. Designed for databases.
Right. These agents are built to interact directly with relational databases, no matter how large, by translating your natural language into the language of databases, SQL.
So the main benefit here is bridging that gap between plain English and SQL complexity.
That's the absolute core benefit. They act as that critical intermediary. You ask in English, they translate it into structured query language, SQL, which the database understands.
And SQL itself, that's traditionally been a hurdle, right? You need to know the exact table names, column names, how they join, the specific syntax.
Oh, absolutely. Learning SQL well requires understanding database schemas, relationships, different SQL dialects, specific functions. It's a skill in itself.
So these agents remove that requirement.
Largely, yes. By providing a natural language interface, they dramatically broaden who can access the data stored in databases. Non-technical users, decision makers, they can now query and interpret data directly without needing to become SQL experts first.
That really is democratizing data at a much deeper level, isn't it? Going right into the corporate database.
It truly is. It allows people closer to the business problems to get answers directly, which can massively accelerate strategic decisions and analysis. No more waiting for the SQL query backlog.
Okay, so what are the key capabilities that let these SQL agents do this effectively? How do they understand the database?
One crucial capability is database schema understanding. The agent needs to be able to essentially read the blueprint of the database.
The blueprint.
Yeah, the schema. That means knowing the names of all the tables, the columns within each table, the data types of those columns, and importantly, how the tables are related to each other, like which column connects the customers table to the orders table.
So it needs to know the structure to answer accurately.
Precisely. This lets it answer specific questions about specific tables, or even questions that require joining data from multiple tables. And importantly, good agents do this efficiently. They don't necessarily load the entire schema for the whole database every time. They intelligently figure out which tables are relevant to your query and just fetch the schema for those.
Smart. Okay, understanding the schema is key. What about complex questions that might need multiple steps?
Good point. They often support multi-step querying. A sophisticated agent can handle a question that can't be answered with just one single SQL query.
How does that work?
It can break down the complex problem into smaller, logical parts. It might run one query to get some intermediate results, then use those results to formulate a second query, and maybe even a third, before finally synthesizing the complete answer for you. It mimics how a human analyst would tackle a complex request step by step.
That's quite advanced reasoning.
Yeah.
What about errors? SQL can be finicky. If the AI generates slightly wrong SQL.
Yeah, syntax errors, wrong table names, it happens. But robust error handling and auto retries are crucial features here.
Auto retries.
Yes. If the AI generates an SQL query and the database throws back an error, a good agent doesn't just give up and show you the error message.
What does it do?
It captures the error message, often called the traceback. It then analyzes why the query failed based on that error. Was it a typo in a column name, an invalid function call? It tries to understand the problem.
And
then often it can automatically correct the SQL query based on the error feedback and try again. This self-correction loop can often resolve common issues without you even noticing, or at least without you needing to manually debug the SQL.
As someone who has spent hours debugging SQL, that sounds amazing.
It's a huge time saver and makes the whole experience much smoother and more reliable.
Okay, those capabilities sound impressive. But surely there are limitations, things to be careful about, especially when you're letting AI query potentially sensitive databases.
Absolutely. We have to be realistic. A major limitation is the potential for inaccurate AI interpretations. LLMs are powerful, but they're not perfect.
Yeah.
They can misunderstand the nuance of your natural language question,
Leading
to the generation of incorrect SQL, or maybe SQL that runs but gives you the wrong answer because it misinterpreted what you wanted. Human oversight, checking the results, understanding the generated SQL if possible, remains essential. You can't just blindly trust the output for critical decisions.
So it's an assistant, not an oracle.
A very powerful assistant, but yes. And for really complex, highly nuanced analyses, you might still need a human touch. Maybe the AI gets you 90% of the way there with the SQL, but an expert needs to tweak it for optimal performance or to handle some edge case the AI missed.
Okay. And continuous testing seems vital.
Absolutely critical. Reliability is paramount. You need to continuously test and validate the agent's performance, especially if you're relying on it for important business functions. Does it consistently give accurate results across different types of questions?
Makes sense. Now, the really big one, security. Connecting an AI that generates code directly to your databases sounds potentially scary.
It is, and it requires careful management. There are several significant security risks. One is SQL generation vulnerabilities.
Meaning,
could someone craft a clever natural language prompt that tricks the LLM into generating harmful SQL? Like a query that tries to delete data or drop a table. If the system isn't properly constrained, that's a theoretical risk.
yikes. Okay, what else?
Prompt injection is another classic AI risk. Can a user embed malicious instructions within their seemingly innocent natural language question to make the LLM perform unintended actions? Maybe try to bypass its instructions or access information it shouldn't?
Trying to hijack the AI's process.
Exactly. And then there's data exfiltration. The risk that the agent could be tricked into returning sensitive data it shouldn't, maybe by cleverly phrasing a query or exploiting a loophole. Unintended data leakage.
These sound like serious concerns. How do you mitigate them? What are the best practices?
They are serious, and mitigation is non-negotiable. Rule number 1. Grant the agent read-only database access whenever possible. Unless its core function absolutely requires writing or modifying data, stick to read-only permissions. That eliminates the risk of accidental or malicious data deletion or modification via generated SQL.
Okay, read only first. What else?
Implement robust input sanitization. Clean and validate the natural language prompts coming from users before they even reach the LLM, stripping out potentially harmful characters or commands.
Filter the input.
Yes. And crucially, use sandboxed environments, especially for development and testing. Isolate the agent and its database connection so that if something does go wrong, it can't affect your live production data. Test thoroughly in a safe space.
Read-only access, input sanitization, sandboxing. Got it. Essential precautions. So, Let's trace the journey again, but specifically for the SQL agent. From my question to the answer, what are those steps?
Okay, the 8-step flow for SQL agents. Step 1, user input. You ask your question in natural language. Let's say, show me the average sales by product category.
Simple enough.
Step 2, agent receives question. The AI-powered SQL agent takes that input. Step 3, LLM interprets and generates SQL. This is the core translation. The LLM inside the agent figures out your intent and writes the corresponding SQL query. Maybe select product category AVG sales from sales data groupie by product category.
Okay, the SQL is created.
Step 4, database connector sends query. A piece of software, the database connector, takes that generated SQL string and sends it over the network to your actual database server.
The messenger.
Exactly. Step 5, database processes query. The database receives the SQL, parses it, figures out the fastest way to execute it, and retrieves the requested data from its tables.
Does the job.
Right. Step 6, database sends raw data back. The database packages up the results, the rows and columns of data, and sends them back to the database connector.
Data's coming back now.
Step 7, database connector passes data to LLM. The connector receives the raw data and hands it back over to the LLM part of the agent.
Why back to the LLM?
So it can perform step 8. LLM processes and formats data. Agent displays answer. The LLM takes that raw tabular data, parses it, maybe does some final calculations or formatting, and most importantly, translates it back into a clear, understandable, natural language response for you. It might say, the average sales for category A were $6, for category B were $, and so on. Then the agent displays that final answer.
So the LLM is involved in both understanding the question and explaining the answer.
Often, yes. It acts as the interpreter on both ends of the process.
That's a very clear flow. It all happens remarkably fast behind the scenes, I imagine. Now, we've talked theory, capabilities, risks, but people listening might be thinking, okay, how do I actually build one? What does it take to get a LangChain SQL agent running?
Right, moving from theory to practice. At a high level, you need to orchestrate a few key pieces. Set up your coding environment, get a database ready with some data, choose and configure your LLM, and then use LangChain to wire them all together.
Like building a pipeline for the question to flow through.
That's a good analogy. You're building a pipeline where your natural language goes in one end, gets processed, queries the database, and a natural language answer comes out the other end.
Okay, you don't need to give us every single command, but can you walk us through the main components and the logical sequence?
Absolutely. So first, best practice is always to create a dedicated Python virtual environment for your project. Keeps things clean, avoids library conflicts, standard Python hygiene.
Good practice. Then libraries.
Then you install the necessary Python libraries. You'll need the core LangChain library, of course. You'll need a library to connect to your specific LLM provider, like it being watsonx AI if you're using watsonx. And you'll need a database connector library, like MySQL connector Python if you're connecting to a MySQL database.
Got it. LangChain, LM connector, DB connector. What about the database itself?
You need an actual database server running. For development, you might spin up a MySQL server locally, maybe in a Docker container, wait a few seconds for it to initialize. Then you need some data in it to query.
Like that Chinook sample database you mentioned.
Exactly. Chinook is perfect for this. It's a well-known sample database, modeling a digital music store tables for albums, artists, tracks, customers, invoices. It has clear relationships shown in its ERD, entity relationship diagram. You download the SQL script for it, chinook-mysql.sql, and then run that script using the MySQL command line tool, source chinook-mysql.sql, to create the tables and load all the sample data.
So now you have a populated database to talk to. How do you verify it worked?
Quick checks in the MySQL terminal. Show databases. Should list Chinook, then use Chinook and maybe select count from album. If it comes back with 347, you know the data loaded correctly.
Okay, database ready. Now configuring the AI brain, the LLM.
Yeah, right. This involves setting up your credentials, again, API key, URL, and defining those model generation parameters we discussed. Max new tokens, temperature, probably low, like 0.1 or 0, TOPK, etc. You'll also need your specific project ID from your LLM provider. You load these credentials and parameters into the appropriate LangChain LLM wrapper class, like Watson XLLM, specifying the exact model ID you want to use, one of the IBM Granite models. This integrates the LLM's power into LangChain's framework.
LM configured and wrapped for LangChain. Next is connecting Python to MySQL.
Correct. You define your MySQL connection details in Python username, password, host name, usually localhost for local dev, port default 3306, and the database name, Chinook. You combine these into a connection string, a URI, Uniform Resource Identifier. Then you use the LangChain utilities, SQL database.formuri, to establish the connection using that URI. This gives you a DB object that LangChain can use to interact with your database.
Okay, almost there. We have the LLM, we have the database connection. Now create the actual agent.
This is the final assembly step. You import creates agent from LangChain. You then call this function, passing it the key ingredients, your initialized LLM instance, the DB object representing your database connection.
And that verbose true setting.
Definitely include verbose true. It's so important for seeing the agent's reasoning, the SQL it generates, the database results it gets back. Absolutely invaluable for understanding and debugging.
Yeah.
You might also specify an agent type, like zero-shot React description. That tells the agent to use a specific reasoning process, think React reason plus act, before acting, which generally leads to better results for complex tasks.
Okay, the agent is created, configured, connected, moment of truth. Run a query.
Moment of truth. You use the agent's invoke method again, just like with the Pandas agent, but this time your question is aimed at the database. For example, agent.invoke, how many albums are listed in the database?
And walk me through the behind the scenes one last time.
Sure. Your question goes to the agent. The LLM inside interprets it, thinks, okay, they want to count from the album table, generates the SQL, select count from album. The agent sends this SQL to the Chinook database via the connection we set up. The database runs it, gets the result, 347. The agent receives 347. The LLM formats this into a nice sentence. And because verbose, true, you see all this, the thought process, the SQL query select count from album, the observation result, 347, and finally the natural language answer, like there are 347 albums listed in the database.
Fantastic. That really ties together the theory and the practical steps. Okay, we've gone deep into the code and the setup. Let's pull back a bit now and look at the bigger picture, the applications, the future.
Yeah, it's worth thinking about the ecosystem. Tools like LangChain are providing the framework, the plumbing, but it's the underlying LLM capabilities that are really driving this revolution in analytics.
What are those core LLM capabilities again in this context?
It boils down to a few key things. Code generation, the ability to write Python or SQL from natural language, is the absolute foundation. Then data reasoning, understanding operations, data types, knowing when to average versus count, how to filter or group based on the request. Chart selection, intelligently picking the right visualization. Not just generating code, but generating the right kind of chart code. And finally, explanation generation, turning the results back into human-readable interpretations and insights.
So where is this actually being used?
Yeah.
What are some real-world applications?
Oh, tons of potential. Think about business intelligence. A marketing manager asking, show me the top 5 growth categories last quarter. Or a sales director asking, visualize customer retention trends by region. Or finance asking, compare regional sales performance year over year.
Getting instant answers to questions that used to take days or analyst time.
Exactly. Empowering faster, much more data-driven decisions right across the business. The speed is a game changer.
And it's not just for big companies, you said.
Not at all. Personal analytics is another huge area. Imagine pointing this at your own data. Show me my spending by category this month from my bank statements. Or correlate my reported exercise hours with my sleep quality data. Or even analyze my work productivity patterns over the last year based on my calendar and task list.
Putting data science tools in everyone's pocket, essentially.
That's the potential, making powerful analysis accessible to anyone who has data and questions.
Looking further out now, what's next? Where is natural language analytics heading?
The future looks pretty exciting. One big direction is multimodal interactions.
Multimodal, meaning more than just text.
Exactly. Think voice-activated analysis. Hey AI, show me sales by product. Or maybe even gesture-based interactions, pointing at a chart on a screen to zoom in or filter. Or combining modalities, maybe circling something on a chart with your finger and asking verbally, what caused this spike? Making the interaction feel even more natural, more human.
Less typing, more intuitive interaction.
Right. Another huge area is automated insight generation.
The AI finding things for me.
Potentially, yes. The AI wouldn't just wait for your questions. It could proactively analyze your data, identify interesting patterns or anomalies you hadn't even thought to look for, suggest relevant analyses, and automatically explain its findings, becoming more of a proactive data discovery partner.
Like having an analyst constantly watching your data.
Kind of like that, yes. A tireless digital analyst. And finally, I think collaborative analytics will be big.
Multiple people working together with the AI.
Yeah, future systems could support teams sharing, refining, and discussing AI-generated visualizations and insights in a shared environment. And crucially, finding better ways to integrate human domain expertise with the AI's analytical power. Maybe the AI does the heavy lifting, but the human expert provides context, steers the analysis, and validates the conclusions. A true human-AI partnership.
That sounds like a powerful combination. Wow, this has been a really comprehensive journey.
We've covered a lot of ground.
We really have. So just to recap the key takeaways, we saw the LangChain Pandas agent is fantastic for that quick data exploration, rapid prototyping with data frames. But you need those safeguards for production because it runs code dynamically.
Right, the LangChain experimental warning. And then the AI-powered SQL agents, bridging that crucial language-to-SQL gap, really democratizing access to big databases. We looked at their key skills, understanding schemas, handling multiple query steps, the error handling, and auto retries.
But also, critically, the limitations, the potential for misinterpretation, the need for human oversight, and those vital security considerations. SQL injection risks, prompt injection, data exfiltration, and the mitigation strategies like read-only access and sandboxing.
Absolutely essential points. Ultimately, what ties it all together is how these LLMs are fundamentally reshaping data analytics. They bridge the gap between our natural language questions and the complex code needed to get answers. They generate code, they reason about data, they synthesize insights.
Making data genuinely more accessible to potentially everyone.
That's the core promise. These AI agents aren't just neat tools, they represent a fundamental shift in how we interact with information. Asking complex questions in simple terms, getting meaningful, actionable insights back almost instantly. It changes the speed and accessibility of data exploration.
It really does. So let's leave our listeners with a final thought to mull over. A provocative one, perhaps.
Garrett.
If AI can now understand our plain English questions, and it can generate all the complex SQL or Python code needed to analyze our data, what does that actually mean for the future of, say, data literacy?
Interesting question.
Does everyone suddenly become a data analyst just because they can ask questions? Or maybe does it free us humans up? Free us to focus on the things machines can't do as well. The deeper strategic thinking, the creative problem solving, the innovation that comes after you have the insight. Does it let us leave the heavy lifting of data wrangling to the machines?
It's a fundamental question about the future of work and skills.
And maybe think about this. What new kinds of questions will you start asking your data? Once those technical barriers are truly gone, what insights are waiting just beyond the reach of your current tools or skills?
Food for thought indeed. Thanks for joining us on the Deep Dive.
Until next time, keep digging deeper.